Alternative notation. Base vectors. We are already familiar with the most common notation for representing vectors, however there is an alternative notation, which is more useful in certain circumstances. This notation is using the base vectors I, j, and k. The vector I is denoted to be the vector of length 1 in the direction of the x-axis, so the following vector. The vector j is denoted to be the vector again of length 1 in the direction of the y-axis. Finally, the vector k is the vector of length 1 in the direction of the z-axis. So, the vector I is the vector 1, 0, 0. The vector j is the vector 0, 1, 0. And, finally, the vector k is the vector 0, 0, 1. Let us now write a randomly chosen vector in terms of I, j, k. So, let us consider the vector 2, minus 2, 0. Then you can write it as the sum of the vector 2, 0, 0, the vector 0, minus 2, 0 and the vector 0, 0, 0. From here, we have the vector 2, 0, 0 is 2 times the vector 1, 0, 0. The vector 0, minus 2, 0 is equal to minus 2 times the vector 0, 1, 0. Finally, the vector 0, 0, 0 is 0 times the vector 0, 0, 1. So, we get the sum of the vectors is equal to 2 times the vector I minus 2 times the vector j plus 0 times the vector k. I've included the last part for illustration, but it should be skipped as it is simply equal to 0. Just for exercising, let us do the vice versa operation. So suppose we have the following vector, let us write it in the original form. So, minus 5 times the vector a plus the vector k is equal to minus 5 times the vector 1, 0, 0, plus the vector 0, 0, 1. So, we get the sum is equal to minus 5, 0, 1. So, as we can see, the two notations are very similar. The x component of the vector in the original notation is the coefficient of the vector I. Similarly, the y component is the coefficient of the vector j, and the z component is the coefficient of the vector k. For the second example again, the coefficient of the vector I is the x component of the vector in the original form. The coefficient of j is 0, and so is the y component of the vector. Finally, the coefficient of k is the z component of the vector in the original form. Finally, let us consider the sum of the above two vectors and their new forms. We map the coefficients of I, j and k, and so get the sum is equal to minus 3i, minus 2j, plus k. This can be written in the original form as follows.